Hello all, today in this video I'm going to provide details regarding another optimizer with CNN. So before moving into the video, I'm just going to make some clarity that some subscribers said that uh, it is fast to just follow up. So the thing is, if you notice our channel means mostly only some difference will be there in every videos. It will be like a continuity of videos only, so only we will just make it fast because it may be like a repeated content. So if you have any doubts, if it is not clear, means you can just make it as a comment. So in that case we will just definitely help you, and definitely we will also try some steps to slow down because it is not planned, but once we get into the explanation, we are just the speed is just increased. So I will just go with this explanation. So initially we are just imported the libraries what we are needed. Then we are just loading our data set. This data set we downloaded from Kaggle, and this is the continuation of the previous video only. Here we are making only one extra corrections, extra modifications, that is extra one optimizer has been added, and it also will have only simple modification. And this data set we downloaded from Kaggle, you can just give us heart disease detection Kaggle data set download, means in that case you will get this data set. The data set we have downloaded is having nearly 14 entries. Among that, the first 13 entries we will be using as the x variable, and the last one, which is the target one, we will be using as the y variable. Then we are getting the info of the data set. Here you can notice that our data is having nearly 14 entries. Among that, only one entry, which is the whole peak one, is then float type, and all others are integers. And then we are describing our data set, and then we are just checking whether our data set is having any null entries. If it is not having null entries, but if it is having, means we have to work with some pre-processing function. Since it is not having any null entries, we have omitted this pre-processing function. Then we are displaying the heat map of our data set. So this is the heat map of the data set. Then we are declaring the x variable and y variable. Within the x variable, as I said previously, we will be using the all variables apart from the target variable. So we are dropping the target variable, and all other, in that case all other variables apart from target will be given to the x variable, and y variable will be using only the target variable. Then with the use of the x variable and y variable, and the test size as 0.2, that is 20% for testing and remaining 80% for training. And by the use of the train test split function, we are determining variables like x train, x test, y train, and y test. Then we are also making use of standard scalar to conversion of vectors for the variables like x train and x test. Then we are getting the shape of the x train and y train. Why? Because within CNN this it will use only three-dimensional data, but if you notice, means our data size is not three-dimensional, it is only two-dimensional. So we have to convert it into three-dimensional. So we are using the reshape function, and we are getting this thing. So this 13 comma 1 we will be using as the input shape within the CNN function. So then we are declaring to moving to the layer description. Here you may notice that the first we are giving the sequential layer, then we are moving to convolution 1D layer. Here we have declared the filter size, kernel size, padding, activation, and input shape as 13 comma 1, which is obtained from the input data set. Then we have given the layers like max pooling layer with the pool size of 2, then flattened layer, dense layer with an output dimension as 128 and activation as ReLU. Then dropout we have give that 0.5, and dense final dense layer as 1. Why? Because our work is a binary classification work. In binary classification work, we will be giving as the number of classes as 1 only. So then in binary classification work, the activation also we will be calling as sigmoid only. Then we are just getting the summary of these variables. Then we are compiling the CNN model by using laws. And optimizer we have called Adam, and metrics as accuracy, and we are using the fit function to train the model. So here you may notice we have used X train, Y train, X test and Y test, and the approaches for 50 approaches. You may notice that here the accuracy is high when compared to validation accuracy. But for a better model, the validation accuracy should be high when compared to accuracy. So in the next step, we are taking some steps to reduce, to just omit this. Thing, and we are making to that is accuracy is less than the validation accuracy. Then we are displaying the model. Here you may notice that training accuracy is higher than the validation accuracy. Then we are also displaying the classification report, and within that we are displaying values like precision, recall, F1 score and support. And then we are displaying the confusion matrix chart. Then to improve validation accuracy, here the only one step we are doing is, previously the dropout rate is 0.5, now it is 0.1. So by this you may notice that all others are same only. So by this, since it is same only, I am just making it fast. So here you may notice that when compared to this accuracy, validation accuracy is high. So by reducing the dropout rate, you may notice that there is a change. So other than that, we are declaring precision, recall, F1 score. Then we have also declared the confusion matrix. Then we worked with SGD. The one, all other layer description are same only. Only difference is the, in the place of optimizer we will be giving us SGD. Then we are displaying the classification report and also displaying the confusion matrix. And then we worked with rmsprop, and we got we have displayed here we have replaced through rmsprop, and we have displayed the confusion matrix and also the accuracy. Then we worked with adadelta optimizer. We have replaced the optimizer with adadelta. Then we have got the confusion classification report and also the confusion matrix. Then we worked with adagrad optimizer. So we have replaced the optimizer with adagrad, and then we have displayed the confusion matrix and also the classification report. Next, in this work, we have worked with adamax optimizer. So the layer descriptions and all same only. Then you can notice that we have replaced the optimizer with adamax, and then we are getting for 50 approaches, and we have so this is run for nearly 50 approaches, and we have got the precision, recall, F1 score value, and also we are displaying the confusion matrix. Then finally we are making an comparison of all the optimizers with CNN we have done so far. Here you may notice that blue color is the Adam one, and this color is the validation accuracy Adam. So this is the one which is in the top, and also this color which is RMS prop also, it is equal to this Adam. All others, now we have declared adamax, so it comes only, takes only some less accuracy. We saw that it is having nearly 91% accuracy. If you see, means it is having only 91% accuracy. So laws also the same. In the next video we will be working with some other optimizer, and just will make an comparison that which optimizer is providing better results. Thank you.